Okay people, just looking here, conic sections, sheet 1. Okay, so this is kind of revision really for most people, because the first question here we're asked to draw the major axis is AB and the minor circle is diameter 90, radius 45. So I'm going to find the center of this. So this is just bisecting a line. So because it's horizontal and I don't want arcs everywhere, I'm just going to mark that at the bottom and draw a vertical line up. So that's where our minor axis is. I'll heavy that a little bit more now so people can see. And we were told there that the minor circle is 90, so I'm going to mark down 45. And this is the minor circle. And here's our major circle. And if you're not used to drawing ellipses there now, I'm going to draw this in red afterwards. So this is our minor axis. That's our major axis. I'll stick a color on them as well, just in case you're new to the subject, but for the majority of people there, you can just fast forward on through this because you're going to know all this. So here's our major axis, here's our minor axis. Now, so I'm going to put on spokes, as I would consider them or call them there just in class. So they don't have to be at any particular angle. So you don't have to have these at 30 and 60 or anything. But it's just an easy, quick way of doing it. So we want to go where it hits the big circle parallel to the minor, where it hits the small circle parallel to the major axis. So that's a point on the curve, and we're just going to do that for every single spoke. So where it hits the major circle is parallel to the minor axis. So generally I do these, if you break them up with the 30-60, they're all going to be lining up. So I do 2 at the time there, then it just speeds it up. So these are parallel to the major. Now there's lots of videos online there on just drawing a video, so on drawing an ellipse, so I'm not going to go through it. And again there, so here are all our points, so I'll draw this quarter first. Now again, you wouldn't be drawing this in an exam using red biro or red pen, but I will because we're doing a video and I want to make sure that it's pretty clear. So that's the end of that. Okay, now something that comes up, you weren't asked to find the focal points, but the focal points is half the major swung from the end of the minor. So they're the focal points of the ellipse, and that's something you're asked for a good bit. So I'll just look at that, but there's our ellipse. Now guys, question 2 here then, even though it says that's question 2 as well, but anyway, it says draw the outline of a parabola in a rectangle. Okay, so a parabola in a rectangle. Now I want to break the height of this into 4, and I want to break half the width of it into 4 also. Now look, just going to check my measurements here. It's not a standard or a common measurement, so I'm going to just use divisional lines there just to revise as well. So I'll just put a line here, 80 long, and I'm going to go 20, 40, 60, so 80. So that's a line, 4 equal distances, and when I join the end of that line to the corner here and join these up, so I just joined that in here. When I bring these in parallel, that divides this into 4 equal distances here. And I want to do the same there now with half the top. So I'm going to put a line that's 4 equal distances. So I'm going to use 4 tens here. So 10, 20, 30, 40. So join the 40 then, the end of my line, to the vertex here and go parallel. So I've now broken this into 4 equal distances as well. So now I want to join the 3 of these to the vertex. So 1, 2, 3, and the 3 coming down are just parallel to the axis of the parabola. So short, medium, and long. So I'll mark these again with the red pen. And just a tip there for drawing these, these straighten out a lot. So my first one here, I can you could draw that light with a pencil, or you'll get away with drawing, you know, that with a set square, because it does get very straight as it goes along. So choices, I could use symmetry here now for drawing the other side of that. So I just want to transfer these across these distances. I'll just mark them with a compass. So how far to the left? Same distance to the right. And finally, so here are my points for the other side. And another way of doing this is just to draw them with a pencil pretty light, and like that. So there is our parabola. Now again, I have other videos done on what a parabola is and how you cut a cone to get it, so I'm not going to get into that here now, because we're going to see it anyway in the next third part of this question. Now question 3 here, then our next question, I'll zoom back from that there. So what are they looking for? It says that the given cone is cut by a plane. Now the plane is parallel to the axis there, so that's going to give us a parabola. So it says draw the cutting plane on the pictorial below. Okay, so that's in the 3D. And illustrate where the cone is cut by outlining the conic. Okay, so they want us to name the resulting conic, which is a parabola, draw the cutting plane on the pictorial, and illustrate where the cone is cut by outlining the conic. Okay, so they didn't actually ask for the true shape of the parabola here at all. So I think we might just put it in anyway for a bit of practice. But basically, we want to show down here. So we want to show the cone being cut here by. Now, I know I'm probably. Yeah, I suppose I'll turn it same alignment that they have here, going in perpendicular to the vertical plane. So perpendicular to the vertical plane, and it's about halfway. Right, so here is my, here would be the base, and will I put in the whole plane? I might, sure, just for the sheer hell of it. Okay, so here is my section plane that's cutting the cone. I'll make that the same height as the top here. So here is the section plane that's cutting the cone, but the actual cut section, on the parabola is going to look, no, we're just guessing that in a freehand sketch. So it's going to look like this. It's cutting it from here. It's going to come up and in and back down to here again. So I will heavy that in with a pen. I probably should have used a color there now, actually. Probably should have. No, I definitely should have. So I'll just put the bottom of that in there. So here is our cut section there of the parabola. And not sure if you can see that there, so I'll just heavy this in as well. So this is the plane that's cutting the cone. That's the plane that's cutting the cone, and that there is the parabola. So it didn't actually ask for the true shape, but I'm going to draw it anyway. I think they're just for practice. Now the easiest way to do this particular one is in a side view. Again, depending on how much you know about these, but I'll just take the easy way of doing this here. So I'm going to just bring in, so that point is on the ground, this point is on the ground, this point is the highest point up in the air. So basically our curve is going from here up to there and back down again, but really we need to find just a few more. So I'm going to just take two random points here. I know I'm making these circles huge now, but I want you to be able to see them. And what I'm going to do here, we're going to be bringing the heights of these across, but I need to take a horizontal section through them to know. So if I chopped through the whole cone at that height in the top view, that's going to give me a circle of this radius. So those are the 2 points on it, and I can bring them over and up, or another even quicker way is I could say then, looking down from above, they're that far to the left and right of the center. And I'm going to do that again then. So if I chop the cone at this height, it's going to give me a circle of this radius, and that's going to give me 2 points that far to either side of the center axis. And this here is our parabola. So I just put the same hatchings on there as I had down here in the 3D. So that's the real shape of our parabola. So yeah, that's a good revision start there, guys. Best of luck with that. See you later.